Good day everyone! Welcome to Matsaya! I am teacher Dennis and today we will explore an important mathematical concept which is the combinations. Have you ever wondered how many different ways you can choose pizza toppings or form a committee from a group of people? These are real-life applications of combinations, which allows us to determine possible selections without repetition. In today's lesson, we will use Polya's 4-step problem-solving method to solve a practical problem involving combinations. Are you ready? In a pizza restaurant, you can get a basic pizza with 2 toppings, cheese and tomato. You can also make up your own pizza with extra toppings. You can choose from 4 different extra toppings: olives, ham, mushrooms, and salami. Ross wants to order a pizza with 2 different extra toppings. How many different combinations of 2 toppings can Ross choose from? The first step in Polya's problem-solving method is to understand the problem. Let's identify the given. Ross is selecting extra toppings for his pizza. There are a total of 4 available toppings: olives, ham, mushrooms, and salami. He must choose 2 toppings, and since the order of selection does not matter, meaning that choosing olives and ham is the same as choosing ham and olives, this problem involves combinations rather than permutations. The question we need to answer is, how many different combinations of 2 toppings can Ross choose from the 4 available options? Now that we understand the problem, the second step is to devise a plan. We will use the combinations formula to solve it. The number of combinations of n items taken r at a time is equal to the factorial of n divided by the factorial of r times the factorial of n minus r, where n represents the total number of available items, which is the 4 toppings, and r represents the number of choices, the 2 toppings. Since the order of selection does not matter, this formula will allow us to calculate the total number of possible combinations accurately. Now let's move on to the next step. Carry out the plan. We need to find the number of ways Ross can choose 2 toppings from a total of 4 available toppings. Using the formula for combinations, we will substitute the values for n, which is 4, and r, which is 2, into the formula. The number of combinations of 4 items taken 2 at a time is equal to the factorial of 4 divided by the product of the factorial of 2 and the factorial of the difference between 4 and 2. First, we simplify the expression. The factorial of 4 is written as 4 times 3 times 2 times 1. The factorial of 2 is 2 times 1. The factorial of 4 minus 2, which is 2, is also 2 times 1. Now cancel out the common terms in the numerator and denominator. The remaining expression simplifies to 4 times 3 divided by 2 times 1. Multiplying the numbers, we get 12 divided by 2, which equals 6. So Ross has 6 different combinations of 2 toppings to choose from. Now that we have found the total number of possible combinations using the formula, let's verify our answer by listing all possible pairs manually. These are the list of possible combinations: 1. Olives and ham, 2. Olives and mushrooms, 3. Olives and salami, 4. Ham and mushrooms, 5. Ham and salami, 6. Mushrooms and salami. So Ross can choose from 6 different combinations. Since there are exactly 6 unique combinations, our mathematical solution is correct. Now let's apply what you've learned about solving problems involving combinations. Here's a new situation for you. A student council needs to select 3 members from a group of 5 candidates: Anna, Ben, Carla, David, and Ella. The question is, in how many ways can the council select 3 members from the 5 candidates? Let's reveal the answer.